Hey everyone, so in this video I'm going to review transformations of functions with you. Today in class we learned there was 4 ways to transform a function. So let's get started. The first way to transform a function would be a vertical scale, and that occurs when your function has a number outside of the function. Okay, so the example we're going to use in the next slide is 3x squared. So 3x squared, the number on the outside of the function is 3. So that means that this is going to be vertical scaled by a factor of 3. And what that means is that the y-axis, every y value is being multiplied by 3. For the next example, a horizontal scale, which is the second type of phase or transformation of a function, you have a number on the inside of the function. Okay, and for example, this would be 3x all squared. In this case, this would be a horizontal scale of a factor of 1/3. So in this case, for the horizontal scale, the biggest thing is that you are dealing with the reciprocal. What this means is that the factor that you're multiplying by is changing the horizontal scale, which is your y-axis, by a factor of 1/3 in this case, the reciprocal of the number on the inside, which is the number 3 right now. The other two cases that you could have is a vertical shift and a horizontal shift. This is when you're actually moving the graph. For a vertical shift, that means you would be on the outside of the function. When you add, you're moving up, and when you subtract, you're moving down. So example would be x squared plus 1. This would be up 1. If you move horizontally, this means left or right movement. This is on the inside of the function. And the tricky thing here is that when you move left, you are positive. So you're adding inside the function. And when you move right, you are negative. So for example, x minus 1 all squared would be right 1 unit. One pattern that you can look at here is that when you are adding or subtracting, that is called a shift. And when you multiply or divide, that is when you're scaling. So right here, you're multiplying on the inside for both cases. So multiplying would be scaling, adding and subtracting would be shifting. So let's look at some examples and describe how these graphs are being transformed. The parent function in this case is going to be x cubed, which is this guy right here. And basically what we're going to do is we're going to manipulate x cubed by changing things about x cubed. For the first example, I notice first off that there's a number in front of my x cubed, and right away I think of a vertical scale by a factor of 3. What that does to our parent function when we look at the table is it takes every vertical number. Vertical would be the y-axis. It keeps the x table the same, but everything in the y-axis is now going to be multiplied by a factor of 3. So negative 8 times 3 is negative 24, negative 3, 0, 3, and 24. The next example is slightly different. It has the 3 on the inside. This means we have a horizontal scale by a factor of 1/3, because you're going to take the reciprocal. What this does is it multiplies the horizontal axis by 1/3, and the horizontal axis is your x-axis. So basically what this does to the table, if you look at the parent functions table, is it takes that table and divides all these x values by 3. So -2/3 would get you -8, and -1/3 would get you -1, 0 would still get you 0, 1/3 would get you 1, and 2/3 would get you 8. So that's what scaling means. A vertical scale multiplies the y-axis, and the horizontal scale multiplies the x-axis. Now the last two things that we talked about were the shifting. When you're on the outside, you're going to be shifting up or down. So this is going to be up 3 units because we are on the outside. Because this is on the inside, you're going to move left or right. Because it's positive, you're moving left 3 units. Okay, so these two examples are examples from the lesson that we did not get to. So I'm going to explain what they're doing. You guys could probably figure them out on your own, but look at what's happening here. This is example 2. In example 2, it says describe the graph G as a transformation of a common logarithm. Now you should remember that the common logarithm is just log x. So they're basically saying what happened to this logarithm. First off, I see this on the outside. When that's on the outside, I know that I was shifted up 3 units. This is a vertical shift. The 2 on the outside right here is being multiplied on the outside, which means I have a vertical scale by a factor of 2. And the last thing I have going on here is the 2 on the inside. It's a -2, which means I moved right 2 units, which is a horizontal shift. The last example I want to talk about was example 3. And example 3 asked you to find A, B, and K. That's your goal. Now the way that this looks, it does not look like the form of this because of the exponent. The exponent's a little funky. Now what we want to do is break up that exponent by using our powers and properties of exponents. And what we can do, which we talked about today in class, was we can break this guy up. And we can break him up by using the idea that when you add in the exponent, it's really multiplying by the same base. Okay, so this is really 3 to the 2x, which is really 9 to the x because this can be distributed into the 3, times 3 minus 2. If I write it in the form of this, 3 would really go in front as your a value, 9 would be your b value, and -2 would be your k value. So our answers here would be 3, 9, and -2. I hope this video helped clear up any confusion you had with transformations of functions. I will see you guys tomorrow.